Hi, I'm Natalie. I'm an electrical engineering student at the University of Virginia, and I'm going to talk about integrated circuits, how they're made, and the people who make them. So you may or may not have heard of integrated circuits, but you've probably heard of computer chips, microchips, electronic chips, and they're in all of the electronics, or most of the electronics you're using today, especially our smaller electronics. So your phone, your laptop, your smartwatch, all of those are made possible by integrated circuits. Integrated circuits are what allowed us to go from computers a long time ago that took up entire rooms to having a computer on your smartwatch or on your phone. So when you think of a circuit, you're probably thinking of a bunch of discrete components, maybe plugged into a breadboard, things like resistors, wires, capacitors, and essentially an integrated circuit takes all of those components and puts them on a very small area so that they can go into things like your phone. We're essentially talking about how you go from this to this. An integrated circuit is essentially a piece of silicon that has a complex circuit etched into it. So silicon is what we call a semiconductor, which means it can be made to conduct more or less. And you can think of conduction in terms of heat. So metal is a conductor. If you have a metal pot on a stove, and you touch it, the heat is going to be conducted through the metal to your hand. But an oven mitt is an insulator, so if you have on an oven mitt and you touch that same pot, the heat isn't going to be conducted to your hand because the oven mitt is insulating it. And so you can think of electrical conduction in a very similar way. With silicon, we can use a process called doping that makes it either conduct better or worse. And being able to control this is what allows us to put entire circuits onto a piece of silicon. So how are these fabricated? The process actually starts a long time before we get to the silicon. An engineer comes up with a circuit schematic, which is sort of like a drawing of a circuit, and they adjust different components so that when they test it, it meets all of the specifications that they want. They then take this schematic or picture of the circuit and go through a process called layout, where they determine where each different type of metal needs to be laid so that the circuit functions the way that they want to. And there's a lot of different tools that we use on a computer that allows us to do this. So once the engineer has finished the circuit schematic and the layout, they send this design to what's called a foundry, where the chips are actually fabricated. The circuit design is the job of an electrical engineer. And as we talk about the rest of the fabrication process, I'll point out some other jobs that are involved along the process. So the fabrication starts with the fabrication of a wafer. And what that is essentially we grow a really large silicon ingot, which is basically a cylinder of silicon, and then that's sliced really thinly, so we have these very thin circular pieces of silicon that we can use. These pieces of silicon are kept very, very clean, so there can't be any dust or any kind of particles that contaminate these wafers. The wafer is then coated in something called photoresist. Once the wafer is coated in the photoresist, we go back to this layout that the engineers created, and this layout is turned into a mask. And you can think of a mask a little bit like a stencil. So let's say you want to make this picture. You're going to start with a blank canvas. You're going to paint the background blue. And then you're going to lay the stencil of the sun over it and paint yellow, lay the stencil of the clouds over that and paint white, and lay the stencil of the sunglasses over that and paint black. When you remove these stencils, you have the picture you want. And the mask works in a very similar way. Where the light hits the wafer, the photoresist is dissolved and the silicon is exposed. Where the silicon is exposed, that's how we control where we're doping the silicon and how we control where we want things to conduct and where we don't want them to conduct. Here we have a picture of an actual mask and a very zoomed in version. It's hard to tell from looking at this what this is, but it does show how incredibly small these circuits are. All of this work is done in what's called a clean room. So even a speck of dust can mess up this entire process. So the engineers who work in these rooms wear what we call a bunny suit, which is a head to toe covering that keeps your hair or any other dust that you may have brought in with you from contaminating the wafers. This is a picture of me and my friend in bunny suits during our undergrad. There are a lot of different engineers at this stage. There are engineers who study the properties of all the different metals that are used. There are engineers who study the actual layout of the circuit. There are engineers who study how to move the wafers around the clean room without contaminating them. So there's a lot of different types of design and a lot of different types of engineers who work in this area to make this possible. Alright, so we've talked a little bit now about the process that our silicon wafer goes through of adding a layer of photoresist, dissolving that layer of photoresist to expose the silicon, and then doping that silicon so that it responds the way we want to and we can create the circuits we want. Once this is done, we end up with a silicon wafer that has a lot of chips on it. It looks like this, and a zoomed in version here, the red outline shows one chip. These are cut very carefully into all of their separate pieces and then packaged so that they can be used in all of our electronics. If you were to look at the inside of a cell phone, you'd see a fairly large L-shaped area that's the battery. And the rest of the components around the battery are integrated circuits, so you see one here, here, and here. Integrated circuits are super cool, and they're what make the technology that we love and use every single day possible. The process that goes into making integrated circuits is also super interesting, and there's so many different people and processes involved. Maybe the next time you use your phone, you'll think about integrated circuits.